So once again, welcome back to this session on routing protocols. This is the part 2 of the same session. So in this particular session, we are going to actually configure the routers and these devices for the protocols that we have already studied. Let's begin it. So this is the thing that we have done so far. We have had all the physical configurations that were required on all the devices. Now the next thing that we need to do is, because we have taken network D, network E and network F as the public IP addresses for the individual networks, we need to provide the IP addresses of this network to the serial ports connected to them. For example, if network D is an intermediate network between router 0 and router 1, then I should give one IP address of this network D to serial 000 and the other address to serial 000 of router 1. For doing it, let us see how we can do it using the command line interface. So enable configure terminal interface serial 0/0/0, enter IP address 13.0.0. Let's say I'll give 2. You can give any IP address, space 255.0.0.0 and no shutdown. So we have configured this router for a serial port 000 with an IP address. Let's save the configuration on this. So exit, copy running configuration to start a configuration. Similarly, the same thing can be done on the other router as well. Just verify whether this has been done or not. So yes, we have configured it. The other way of doing it is, you can go to the configuration tab and just select the interface which we need to configure and just type in the IP address. Let's say I'll leave it 3 and switch it on. Just write down the addresses which we have given. So 13.0.0.2 to this port and 13.0.0.3 to this port. The same thing should be done on all the other interfaces as well. So for serial 0/0/1, we just go with the command line interface. We need to select the interface serial 0/0/1 IP address 14.0.2 space 250. On this router 2, same thing. See, just select the port serial 000 and type in the IP address. Let's say we give 3. Same with the other remaining things. So network F 15.0.0.0 should be given to serial 0001 and serial 001 of this router. So on CLI mode, select the interface serial 0/0/1 IP address 15.0.0. Let's say 2 space subnet mask. Shut. And this port serial 001 15.0.0.3 and switch it on. So now we have actually provided the IP addresses to all the serial ports as well. Now the task is to configure the routing. So this is what we did, is the basic configurations that can be done to create any topology or any LAN. Now the next task is to come up with the different protocols that we can configure. So on the same topology, we are going to configure the static route. We are going to implement the RIP, OSPF and EIGRP as well. First, let us start with static root. What do we understand by the term static root? Static root simply means that we need to provide the path for routing a packet from one network to the other network statically. Statically means manually. So as a user as an administrator of certain network, I should decide what path my packet should follow to reach from my network to the other network. So for example, if this is my source machine, and if I want to route a packet from this machine to let's say network C, what should be my path? I should decide it. So when I'll send a packet from this device to the router should take the decision that manually what the administrator has configured. So if the administrator has configured that the packet after coming from network A should go to network C via this path, so he should configure it in that way. So for doing it, let us first check whether we have successfully given the gateway addresses. So yes, we have given the gateway addresses to all the devices. Now just go to the router. On CLI mode, we should type IP route destination network address. So for me, the destination for this packet is network C. Destination network address. So on this router, IP route destination network address is 12.0.0.0. destination subnet mask and next hop address. So understand the concept of next hop is like, if a packet is reached here, then what should be the next point where it should go? So in this particular example, we have only two possible options for the packet. Either the packet can be routed to this line or to this line, but manually and statically we are deciding that the packet should route to this place, to this line. So the next hop for this router should be serial 001 of this router. So just configure it that way, and the address given to that particular port is serial 001 is given 15.0.0.3. So just provide the IP address 15.0.0.3, enter. This will route my packet from network A to network C, but then I need to provide the return path as well. So if a reply is getting executed from this network to this device, then it should have a return path as well. So again, same thing shall be done on the router 2, wherein I shall configure it for the static route. So IP route destination will be changed now because the packet is in network C. I shall this will be considered as the source network now, and this will be considered as the destination network. So it will have 10.0.0.0 space 255.0.0.0 space. Next hop for this can be either serial 001 of router 1 or serial 001 of router 0. So in our case, let us assume that we want it to be serial 001 of router 0. So the IP address that we have given is 13.0.0.2. So I think it is incorrect. So let us change it. It should be in the range of 15. So yes, it is 15. Just provide it 15.0.0.2, enter. So we have configured the network in such a way that the packet should be routed from this device to network C, and the path we followed is this one. Let us simulate it just to check whether whatever we have did is been working correctly or not. just switch on to the simulation mode and route a packet from network A to network C, and just see whether the so it gives a failed message because the first time we send the packet, the routing tables are not generated. So let us once again check the simulation and just verify whether the packet is being successfully routed. So you can see the path whichever we have set is being followed throughout the transmission. So it is giving a successful message. That means we have configured a static route from network A to network C. Same thing should be done on the other routes as well. So for doing it, we'll just go very fast with the other way of doing it. So in the routing tab, we can click on the static option and just provide the IP addresses. So for routing a packet from network A to network B, I shall write the destination address, that is 11.0.0.0, subnet mask 255.0.0.0.0, and next hop for reaching here is 13.0.0.3, and add it. Similarly, the reverse path on this router, I shall configure my port number 000, which we have configured. On this router, I shall configure 000 with 13.0.0.2. So I shall go on this static and just provide in the address. So network would be 10.0.0.0, 255.0.0.0, and next hop for reaching here is 0.2. Add it. Same thing on this router as well. Set a static path from network C to network B. So for doing it, network B's address is 11.0.0.0, 255.0.0.0, and next hop for reaching here should be 14.0.0.2. So let's provide it. 14.0.0.2. Let's add it. Same thing here also. Static network should be 12.0.0.0, and 14.0.0.3. This invalid subnet mask. Add the path. So in a way, we have configured a static route on all the networks. Let us check whether the packets are properly routed or not. So this is from network A to network B. The packet is getting failed. Once again, we shall try it. And we are successfully able to receive the message. Similarly, we can check from network C to network B. So we can see that all the networks are now being able to communicate with one another successfully. So that is how static routing can be performed on a set of number of networks, and this is how we can verify using simulation mode.